Welcome back to Air Quality Matters. I'm Simon Jones, and coming up, a conversation with Mark Lynn, Managing Director of sustainable insulation firm Eden Renewable Innovations, and also Chair of the Alliance for Sustainable Building Products. The Air Quality Matters podcast was live a few weeks ago in London for the Alliance of Sustainable Building Products annual Healthy Buildings Conference. We took the opportunity to sit down with its chairman, Mark Lynn. Mark has over 2 decades of experience in the field of natural fibre insulation and nearly 30 years in natural building materials, having spent the early years in his career in timber preservation. With a background in science and business, Mark is an ardent believer that healthy and sustainable buildings is achievable at scale, and he takes a particular interest in building physics and the chemistry of building materials. Building materials, if you think about it, and their impact on the environment, particularly air quality, are profound and a key determinant in the sources of pollutants we bring into our buildings. The conference, and by extension our conversation, was centred around this theme: the importance of material selection, basic hierarchies of control, and understanding how material technology can also be a tool in the toolbox of moisture control and air quality management in general. It was a fascinating day, and likewise a fascinating conversation with someone with deep expertise on the impacts materials have on our spaces. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Mark Lynn. I think what I've found really fascinating talking to you has been really bringing up the importance level again, materials, because I forget, as everybody else does, I think, you get caught up in the world of engineering of buildings and HVAC systems, and we forget that there are some fundamentals here when it comes to managing risk and healthy spaces. And materials are front and centre there, yeah. But somehow I think they get forgotten, don't they, in the conversation?
Well, it's funny. I was thinking about this after our conversation and before the podcast, and I was sort of going back to about the sort of mid to late 90s. I don't know if you remember, but there was this sort of influx of home improvement programs where Bobby the Builder, or whatever, would turn up at a person's property with a ton of MDF. And they'd renovate a house with a ton of MDF. And then there was a lot of negativity about the amount of formaldehyde that was off-gassing from that material. And then around that time, it led to changes or restrictions in the way that MDF was made in order to reduce those. And that also coincided around the time where the movement towards abolishing smoking in indoor spaces was really gathering momentum in advance of the ban that I think came into force in 2007 or in Ireland 2004. So there was a point in the past where where our indoor air quality really mattered, if you're using those two things as a proxy. And I think that also coincides with a point where ventilation moved up the agenda. And I just wonder if it's sort of around the early 2000s, there was an inflection point where the means of dealing with all this stuff that we were creating or that was spewing out from our buildings. The solution to that was to ventilate. If you think we moved from a movement where indoor air quality and our focus on it was probably at its highest point, to now where it's at its lowest point, arguably. And what's caused that? So we've shown as a society that we do care at some point about indoor air quality because we did at that point, and now we don't.
Yeah, that's interesting. You mentioned inflection points. I was only musing on this the other day about the way society progresses through time, and you get these kind of step changes, don't you, or these inflection points where there's a shift. We saw it in the 70s with the fuel crisis and people trying to ventilate less and seal buildings up and try and save energy. We saw it in the I suppose the 80s with sick building syndrome starting to really gain traction, particularly in kind of non-residential spaces and people looking for answers there. We've seen it through history with things like asbestos, you know, in the built environment, and understanding and recognising the risks there. So it is interesting that you get these kind of inflection points. And you know what, there's a great image I saw. I've mentioned this before, actually. I really need to dig it up. It's a beautiful image of your living room growing up, right? It was definitely my living room growing up, and it was a picture of a 70s living room. And the point of this image was that every single material in that living room came from England, apart from one product, which was the quartz clock on the mantelpiece, came from, I think, Japan, right? But everything else, Bakelite, you know, wool, nylon, wood, timber, everything in that picture was local. But also, interestingly, you could probably count on two hands the amount of materials actually in that space. You know, it was quite a simple space in that regard. Now, we got some of it wrong. There was lead in paint and things like that, which we learned, but it was quite a simple environment. And then next to it's a picture of the living room my children grew up in. And not one product in that living room came from the country we were living in. And there were probably 1,000 different materials, you know, subdivisions of various plastics and materials and chemicals and stuff. So I think you're right. We care a little bit more. But our indoor environment got a hell of a lot more complicated over the last 20 years, didn't it? The materials that we've been able to stuff in to a space.
Well, I just don't think we've thought about it. And it's trying to get people to understand that message. And sort of all that stuff, you mentioned that all that stuff was manufactured outside the UK. I grew up in Belfast, so I don't think most of the stuff in my living room was made in Northern Ireland. I think the only thing that was made was probably DeLorean cars, and they didn't last long. Yeah. But the point is that, you know, we look and we say, for example, why are we bothered about reducing our emissions or our impact when it's China and India and so on and so forth that are making all the emissions? But they're making the emissions to satisfy the way we consume. We're buying that stuff. And not only, and it's a good point you've made there, not only are we offshoring our carbon emissions and our pollution to these countries, we're actually bringing the pollution back to our own homes, because the ingrained impacts of those materials and what they do within our living spaces has a real impact on our health.
Yeah, and you come from I know you come from a kind of a chemistry background. Does it concern you that we probably don't even know some of the impacts that are to come, like epidemiologically, you know, long term, for some of the materials that we've introduced into our homes over the last few decades? Because, like, in some ways, we're only seeing the results of the stuff that we brought up through my childhood, and because it's not until you start reaching older life that those chronic illnesses and injuries start to occur. So you do wonder. I know Joseph Allen talks about this grand chemical experiment, but in a way that's what it is, isn't it? That we've introduced a multitude of materials into our buildings, and I'm not sure we even know what the impact of those are going to be, you know, on my kids' future who've grown up in that space.
Yeah. It's interesting, really, because I suspect that room, your childhood room, living room that you talked about, didn't really change much for the best part of a decade, and you probably could have taken a photograph at the start of the decade and the end of the decade, and not much would have changed. Whereas now it's not just what we're loading our living spaces with, it's the churn of materials. And, we've sort of moved from everyone just sticking everything in landfill to that's getting moved to a recycling centre, which is sort of, a charity shop. It's not a bad thing. But the point is, why do you constantly need new stuff? So a lot of that is about our attitude to consumption and how we consume less. And it's interesting because, I'm renovating a chest of drawers at the minute that I picked up for about 70 quid. Really nice, late Victorian chest of drawers. And it was very beaten up. And I thought, well, I could do something with that. And when I started taking it apart, I saw that in pencil, the people who had refurbished it before me had put the date that it was refurbished.
Wow.
It would have been late Victorian. It was refurbished by someone in 1933, and then again in 1998, and then in 2006. It's trying to get a feeling of just what that's like, to have a piece of furniture that is, functional, looks nice, and has got that history to it. Surely that there's more utility in that than just going to IKEA or equivalent and just buying some new piece of kit every 3 or 4 years and sending the old one to a charity shop.
Isn't that interesting? Yeah, and it's I know we're going off on a massive tangent here, but I think it's a fascinating part of the conversation. It's this idea of ownership. That chest of drawers, like, your perspective of it is that you're just the custodian of it now, right? And somebody else will be the custodian of it in future. I think we've lost a lot of that, both in our buildings and also the materials that we put into them. If you think back even half a century, a lot of the stuff that was in those spaces, I think people genuinely saw themselves as custodians of those beds and those bits of furniture and even the building itself, that this wasn't yours and that you had to replace stuff.
Yeah.
That this was just yours to maintain and keep and pass on in some way.
And the evidence and the legacy of that, and the fact that I think that's still in us, it just needs to be found. When you look at the adages, make, do and mend, quality, not quantity. But buy cheap, buy twice. All those things, they date from a time where sustainability and the impact of how we consume wasn't on the agenda. And adages are important because they're a very clear way to reinforce a good message and for people to remember things. Now, what's that got to do with indoor air quality or anything else? Well, the simple thing is, quite often new things emit more stuff. And the more churn you have of new materials within your living space, the more new stuff is off-gassing new materials or new pollutants. And as you said earlier, we live in a chemical soup. It's not just the pollutants that are coming off materials or not being adequately ventilated. It's the reactions between them, isn't it? And the fact that Professor Stephen Holgate's doing a presentation at the Expo today, and I'm no doubt he'll cover this, that microparticles are a host for chemicals to sit together and react. It's probably a bit like an asteroid. An asteroid in space is a host to a whole load of chemistry that's going on. And creating chemistry, well, these microparticles with the indoor air pollutants that we have are almost like just little hosts for reactions. And the one thing about microparticles that maybe isn't appreciated is that they're so small, they behave like a gas and they can move anywhere in your body.
And I think that's not appreciated enough, actually, is that these dust particles, they don't just suddenly appear and disappear or appear and end up in your respiratory tract. They can often be in an environment for quite a long period of time, particularly if they're kind of carbon-based. They'll resuspend, they'll settle, they'll resuspend, and on their journeys, they're landing on furniture, picking up fire retardants, then they'll resuspend and they'll land on a shelf and they'll pick up paint material, and then they'll resuspend and they'll pick up chemicals from your air cleaners. And by the time this is all reacting together with moisture and all UV and all sorts of other lovely stuff. And, it's a great piece of chemistry going on live in our spaces. And yeah, this stuff's really complex and we just don't know. And Stephen's a really good advocate for this idea of particles being like a Trojan horse almost, that they're just a carrier, really. They enable the transfer of some of this stuff into our body. So we just don't really know. And I suppose back to the original question I had for you, that's what I think we've forgotten a lot with particularly materials in buildings, is how fundamental this is to outcomes, because it is those materials that are introducing the unknowns into that space. And we spoke about this when we spoke before, the hierarchies of control are there for a reason. You talked about this idea of kind of, what you call it, hurdles, setting up hurdles, or Kath Noakes would call it the Swiss cheese idea. But, effectively it's this idea of basic systems of control to manage risk and elimination and substitution of risks, so products with chemicals we don't want in a building is top of the pile for a reason, isn't it?
Yeah, well, it's interesting, going back to what we said at the start about pivot points. There was a pivot point within natural materials, in particular natural fibre insulation, around the sort of 2004, 2005 time. There was a lot of talk about breathability being irrelevant because moisture is removed through ventilation. And this goes back to the hurdle technology, really. And the hurdle technology is quite straightforward. You put a number of barriers in place for a specific risk. You don't rely on one because you don't know if that's going to be successful or not. The most obvious example, I guess, was the Titanic. They said that you don't need lifeboats because we've compartmented the ship and it can't sink. Yeah. And lo and behold, the compartments failed, and they didn't have enough lifeboats for the survivors. Same with sort of air quality within buildings. So if you look at the hurdles that can be put in place, one obviously is ventilation, good ventilation. I think what's been demonstrated with ventilation is that the quality and the workmanship is important, and the maintenance. So don't just put a ventilation system in and forget about it. That doesn't end well. But then you look at materials like wool, like wood, and other natural materials that can uniquely buffer moisture, because which is another hurdle. Because obviously, if you can have something that can hold moisture safely, you're reducing the risks associated with humidity and moisture and the impact on air quality. And then choosing materials in the first instance that emit less pollutants. So there's three obvious hurdles. And when you're looking at moisture, for example, we're woefully behind other industries like the food industry when it comes to understanding how the impact of moisture and how to manage moisture and make materials work better and more effective within the humidity environment that they're exposed to. I suppose when you're looking at, and they do that because in the food industry, moisture causes acute health problems, food poisoning being the obvious one, and acute economic problems. In the built environment, moisture causes chronic problems, and we ignore distant consequences until they become acute. And if you look at the knowledge around moisture and water activity and the chemistry that goes on between carbohydrates and moisture, food industry is probably 50 years ahead of construction. And you think, well, what's the food industry got to do with natural building materials? Well, the chemistry of a shredded wheat and the chemistry of a wood fibre board are pretty much the same, because starchy materials and cellulose are just different lengths of polymer of glucose. So the carbohydrates, they're polar molecules, and they interact with moisture in the same way. So effectively, as humidity rises, the polar, I'm going to get a bit chemical here, but the polar parts of a carbohydrate that are have a slightly different charge, they attract water molecules like a magnet. And so at a given moisture content, be it shredded wheat or a wood fiberboard, wants to be at a very specific moisture content at a given relative humidity. And we know that as temperature fluctuates, humidity changes. So the natural fiber can interact with the material, with the humidity, and moderate it and buffer it. Now, because that's a very predictable thing, the food industry has taken that and used it to their advantage. So, they've developed the Jaffa cake, where there's a lot of moisture in the jelly, but it doesn't make the sponge soggy, because they understand the chemistry of how moisture reacts or interacts. It keeps saying reacting, it's sort of interacting with natural materials. And we need to appreciate that more. Yeah. Now, the reason why we've done nothing, not industry, natural fibre insulation companies are obviously doing stuff about it, but we're small in comparison at the minute. But things haven't moved on as they should have done because for the last 20 years, we've been living in the shadow of this attitude that you don't need to do anything because ventilation is the sole solution for everything. When in actual fact, we need to look at, more multifaceted approach.
I don't want to divert the conversation, but I will try and find a link for the show notes for people to go and look at the Jaffa Cake lawsuit, because that's just a fascinating discussion about whether something's a biscuit or a cake and deserves to have tax or not. And if you haven't heard that story, it's a wonderful description of industry arguing a legal case to avoid being penalised for tax. But it just goes to show that the entire fundamental legal argument of that Jaffa Cake case was whether something's a cake or a biscuit based on whether it's soft or crunchy or hard. But that's managing moisture risk in that product down to a T. I've used I think the last time we spoke, you mentioned the Digestive biscuit. I've been using that actually ever since I spoke to you, because I think it's fascinating that there's more science in the moisture management of a Digestive biscuit than there probably is in most buildings. But
there's a whole body of research on this. It is jaw-dropping, the amount of research that's gone into water activity and food products compared to water activity and natural building materials. And when you see the clear link between moisture and humidity within the building fabric, and indoor health, why wouldn't you incorporate that as one of your hurdles, if you like? And I think when you're going back to this sort of, again, I think this sort of mid-2000s sort of pivot point where, that's 20 years ago. Things are due to change, aren't they? Just through that natural cycles you talked about. Around that time, the argument was breathability is not relevant because 95% of moisture is removed from a building through ventilation. I'm not going to argue with the fact that 95% of moisture is removed from a building through ventilation. What I'm arguing with is the fact that the 5% that remains is not relevant, because it doesn't take a lot of moisture to cause an awful lot of problems. All you've got to do is turn your fridge off for a week, unplug it and leave the door closed, and see what the tiny bit of moisture in that fridge is going to do to the thriving mold life that appears out of nowhere in a very short space of time.
Yeah, and I think that ventilation analogy is an interesting one, and it really points to your kind of hurdles principle, this Swiss cheese principle, is that the assumption is that ventilation is functioning correctly in that calculation. So what happens if you've miscalculated how much ventilation that building needs, or like we find 75% of systems aren't doing what they should do? What have you left yourself with as a backup, as a buffer, or redundancy? And that's what engineering is all about, is understanding those risks and building in redundancy. And the assumption of we don't need to deal with this problem because something else assumes that something else is going to take care of it. I think I was making a note there that I think that's the interesting thing about sustainability and the natural building materials and sustainable building materials, is that they've got a much more typically holistic world view of the benefits that they bring than perhaps we have done with some of the petrochemical based materials or some of the more technology focused materials, because they're my sense is, I don't know if you agree, that often it is the case that there's this assumption that we can fight against the environment somehow if we've got modern materials, that it's the building against the environment, not working with it. You know, we don't need to manage moisture because we can engineer it out through ventilation. Yeah. You know, we don't need to worry about vapor control because the ventilation will handle it. Yeah. You know, whereas sustainable building products and natural building products have gone, sure, but actually there's another way of looking at this. Yeah. You know, we can be part of a bigger picture.
Just picking up on one point there, really, you know, is the technology. Natural materials are technical. There's a lot of technology in there. Even if you don't add a lot of technology to wool, for instance, I'm in the wool insulation business. Wool is something that has evolved in nature over millennia. You know, not even artificial intelligence can recreate that. So you've got natural technology. And maybe it's this decoupling of the notion of natural materials and technology. And, you know, the technology, what we do with our products, and it's the same with a lot of natural materials, all you're doing is picking up on technology that evolution has developed and making it relevant.
I'm guessing if you were setting out from day one to create wool, it would be an incredibly technical endeavour. You know, it just so happens to exist, you know, and when you look at it, it's a really technical product as it goes. Yeah. But actually, if you were to start from scratch and go, I know what we should try and invent. We should try and invent this material that does this, and this. You'd be going, wow, that's not easy. You know, you can imagine the chemists and the engineers in the room going, you want to do what now?
Well, and you would, you know, if you think about the sort of energy and the impact you would pump into that, and I suppose the most obvious example would be sort of, you know, synthetic cellulose-based fibers that are aimed at sort of replicating natural cellulose fibers. Well, you basically got to break down the cellulose with a lot of chemicals and a lot of energy to rebuild what you started with, more or less. So, you know, we've a lot to learn from that. And I think, you know, I would like to feel that, you know, change is accelerating in this. And not just for sustainability, because the one thing that sustainability and indoor air quality share in common, of course, as a movement, if you like, for the last 25 years, is that we've all felt like we're pushing water up a hill. And eventually we've got to get to the top of the hill. And having seen a number of different iterations, I guess, and a number of different false starts, you know, I'm optimistic that, you know, that we're not too far away from a change in how we view things. We have to be, because, you know, when you're looking at over the last 4 years, I guess, the change that we've faced as a society and the realities that inevitably are going to hit home.
Yeah. Do you think that's realistic optimism? Like, what's your sense looking? I mean, you've been involved in this sector now for a long time, so I think you've seen the trajectory from when you started. I imagine you were knocking on doors and people were going, you want to sell what now? Where is the industry today? Where are the differences in awareness to these natural building materials and off-gassing and health benefits and risks of materials? Are there sectors or parts of the world that are more ahead of the game than others? And are there things that we can learn from that, do you think?
I think it happens quite often that things don't look like they're changing, but when they change quickly. History shows us that. So that's grounds to be optimistic. And at some point, if things change, hopefully they change in your favour. They can't continually change against your favour. And the other thing, I guess, is that if you're 1,000,000 miles from something and you get to 1,000 miles from something, that's a huge leap forward. But 1,000,000 miles from something and 1,000 miles from something, when you're looking at your destination, don't look any different. So I guess it's how we judge success. And there's a generational thing. You know, one of the things that my generation or later generations might show is that we're going to be the ones that probably show the impact of the chemical experiment that we've been living with for the last 60 years. You know, so hopefully younger generations might see that. But of course, younger generations are the people that have got to live with the consequences of climate change much more than certainly I do. So there has to be a sort of generational imperative. I think we need to have a shift away from polarization. How do you do that? Well, we've got to show what the standard is. But showing what the standard is doesn't necessarily mean that everyone has to be the same as that standard. Because if everyone aspires to be the same as something, then we result in a polarized world. What we need is to set a standard where people feel like they can be a bit more like that. You know, people want to be a bit more like the good, and it's down to us to show what the good is. And if everyone can be a bit more like the good, then surely that's, when you're looking at the aggregate impact, is progress.
I'd like to borrow your attention for just a moment to discuss ACO, a partner of this podcast. ACO, an EI company, specialises in pioneering new technologies in fire, carbon monoxide alarms, and Internet of Things technology. Many know them as the go-to company for these products. In fact, this year they're celebrating 35 years in business. I particularly know them for their outstanding work in the housing sector with their HomeLink offerings, aiming to solve some of the industry's most serious challenges. The technology incorporates environmental sensors and a gateway to offer connected home solutions, which has a proven track record in helping landlords reduce operational costs and carbon emissions while improving residents' well-being and safety. Issues at the heart of the housing sector, like damp and mould, fuel poverty, and energy efficiency, are all in the crosshairs of ACO. I've been amazed at how they are innovating here, with a laser focus on unpacking some of the complex nature of these challenges in a way that answers the what next question we so desperately need at the moment. They have a great network of experts and installers. If you're in housing, they are definitely worth talking to. Trusted is an overused word, but not here. Ask around, and ACO are synonymous with it. Details are in the show notes and at airqualitymatters.net and at ACO. That's aico.co.uk. Now, back to the podcast. Standards is an interesting one, isn't it? And I know that particularly sustainable building products and natural building products that are bringing products to various markets struggle with this, because often you're swimming against the tide of an existing industry with existing standards that were written for that type of material, and often it's not that the material isn't capable of meeting a standard, it's just that the standard isn't fit for purpose for the material. And that can be a huge barrier, can't it, for market entry, for all sorts of, I've got a friend up in Scotland who was trying to introduce natural fibre into housing work up there and found it incredibly difficult to comply with things like PAS 2035, which is a standard in the UK for retrofit, because there wasn't something that fitted that material, so then they're taking that risk or having to do something outside of a standard work. That's a huge challenge, isn't it, for that sector? Yeah, we need standards that are fit for purpose and an ability for the standards to keep pace with change. Now, the challenge we've got, of course, is if you build a lot of latitude into a standard so that you've got the flexibility to keep up with change, how do you police the bad actors, if you like, that are using that latitude for
the wrong reasons.
Sure.
You can't assume everyone's a criminal. I don't anyway. I like to give people the benefit of the doubt. So it's trying to have standards that keep up with development, of a market and encourage innovation. Yeah. And we've got this attitude, I think, in construction where if you haven't used it for the last 50 years, don't use it. The point being, whatever we've been using for the last 50 years has probably caused a big lump of the problems that we're currently facing into. So that doesn't make any sense, but it's ingrained. But it's trying to get something to click, isn't it?
Yeah, it's the great standards dilemma. I think. I mean, I've been involved in innovative products, trying to work into a market where it's not accepted, and you're having to find ways of getting that product accepted and eventually changing standards to adopt that new innovation. It's a very long, slow road, and even with the backing of a big multinational, can be incredibly hard. If you're a small innovator or a startup, it's an impossibility often to change that world. My hope for that, I think, is that what we're also seeing with the construction sector more than we've ever done before are feedback loops starting to appear that we wouldn't have had. Construction's been very conservative and traditional, I think, over this millennia, and changes in materials and approaches to building have been generational. It's why we call buildings Edwardian or Victorian, because they've moved that slowly. But I think with the advent of low-cost sensors and digitization and measurements, we're able to assess what really matters, which is the ongoing performance and outcome of a building, rather than the theoretical compliance at handover. And I think sustainable materials are in that picture as well, aren't they? That we're seeing feedback on whether a product is working in a much faster time frame than we would have done 50 years ago.
It's that post-completion monitoring and testing is really important. And that's a really interesting point, because when I first got involved in natural fibre insulation, going back 20 odd years now, I guess, I was sort of looking at the acoustic insulation market and how they were able to add value to products. But within the insulation market, you couldn't, which is absurd, really, when you think about it. All insulation pays for itself in a relatively short space of time. So, you would have thought that the number one natural material you could very easily sell to someone is natural fibre insulation, because you say, well, it'll pay for itself in 5 years, and then it will pay, so it actually, in financially, I guess, it's one of the few assets that, in a way, appreciates. But we struggled with that. We still struggle with that. But when you look at acoustics, there was a lot of post-completion testing. So there was less incentive for a contractor, say, to try and cut corners and switch products, because there was a risk that if they did with acoustics, then there would be consequences to that. Whereas we've had this environment for a long time where it's just too easy for a client to spec want a product specced in order before completion for it to be switched for something that is claimed to be similar. Well, when it comes to natural materials, only natural materials can react with moisture in the way that they do.
Yeah, that's interesting. That brings me on to this idea of transparency, and I think one of the ways that you can combat slow-moving standards or regulations is through radical transparency, not only in the performance of the products by ongoing measurements and so on, but also being very open about what's in the products as well. I think a lot of that can allay a lot of fears, but also combats, I think, a lot of what you were talking about there, of this kind of equal or approved nightmare that happens all the time in the building industry, where somebody comes along with something that's £5 a square foot cheaper, and says, well, it's similar, and then throws a load of material at somebody until they're bamboozled to the point that they can't really argue anymore. And they go, oh, okay then, plus I'm saving a few bob. Like this thing happens all the time in construction, and I know you can invest an inordinate amount of time building a relationship with somebody, with trust with somebody, organising them to start trying and piloting projects and so on. You do all of that hard work, and then last minute something comes in, equal or approved, and you're like going, where's that gone?
I know.
Where's that customer gone?
As someone that runs a business, it's sort of very unfair that you have to factor in this massive attrition rate, where you know that you're putting effort into something and there's a high probability it is in vain, but you sort of play a numbers game. You use your intuition to know what ones to walk away from. But, that takes a long time, and you probably get it wrong more than you get it right. But it's a big investment. And the thing is, the unfortunate thing is that when people are specifying sort of natural and sustainable materials, they're doing it for good reasons. And those good reasons don't change. You can't get to the point where a material switched out for sustainability or health reasons or whatever else. And the reason for doing it is that it suddenly vanished. It all boils down to pounds and pence at the end of the day.
Like you don't mind, I don't think anyway, presenting a choice to somebody and it's just not a runner because it's nowhere near the framework of costs that they have in mind for that construction, right? If you're proposing something that's genuinely going to fundamentally change the overall cost of a building, fair enough. But it's when you lose work and projects on small fractions and you're going, really? Because if you're explaining you're losing, you can explain all day long about what the iterative benefits of this product versus that product is. But at that point, you've often lost the work,
I guess I'm fortunate in that I'm a decision maker in that respect. So what we don't do in our business is try and sell everything to everyone. And I think when you're looking at a lot of construction products, there's that, how do you get growth? That constant need for ever greater growth. And you reach a point where you're selling to markets where your product is suboptimal or it's not appropriate because you've exhausted your existing market and you're being pushed to grow and grow and grow. I don't do it as much these days, but I spent a lot of time in trade shows. I would spend more time telling people that our product wasn't suitable for them than actually trying to sell a product to them that was, that was right for their needs. And I think that's what you need when you talk about transparency. It's not just about it's not just about being open about what's in your product and what the impact has, but it's also about being open about the suitability of what you're offering for what the customer wants, and not try and sell to everyone that shows an interest. To understand what's your opportunity and what's someone else's. Because the fact of the matter is, you cannot build the entire building stock in the UK from 100% natural materials. Therefore, other things have to be used. And that's why with the ASBP, we've got a materially agnostic approach. If you look at the members here, they cover a whole range of materials, not just natural. We started off, funnily enough, with natural fibre insulation and a bit of a pushback on the Green Guide. But, we've moved to a variety of materials. We take an agnostic approach. And the important thing is to acknowledge that those materials have a place. And it's down to us to sort of help, promote a movement in the right direction towards the right goal, if you like.
Yeah, I remember having a chat with the SPBB a few years ago now. I can't remember, probably at the Future Build conference, I think it was, and chatting to, I think, Debbie about it, and she was talking about plastics in the ASPB, and I was going, that seems like an anathema really, but she was going, well, yes, but then if you think about sustainability, sustainability is about doing the best you can with the right materials, and and it's that covers a whole range of materials. There's an approach to all sorts of products that are the right thing for that particular building. we're not going to make ducks out of cardboard, right? Or cellulose or wood fibre, because it's just not going to work. So there has to be a material, and if you're going to use a material, what's the approach to that? One of the questions I had for you was, do you think that providing the right focus on materials and getting people to make the right choices, it is helped by understanding the risks better? What I mean by that is one thing I noticed in ventilation was when the stakes were high, when people realised they were on the hook, either because of a big change in regulations or there was a big impact potential on health, we saw the focus really zero in and people start to go to the experts and really care about the decisions because they recognised they were on the hook for something really important. Either it was a big risk to the business if they got it wrong, or it was a risk to health or reputation if they got it wrong, and so on. That this is the challenge for materials, is to say this isn't just about the cheapest material, which one is going to last the longest or look the best. That there are some critical decisions you're making here that impact health and well-being and sustainability and carbon emissions and stuff that really matters. And this isn't, so you need to tread lightly here. This isn't something you can just dismiss and chuck products in because it's a few bucks cheaper. It is part of this a presentation of risk problem. A friend of mine said, it's all very well talking about healthy buildings, but are you ready to take on the responsibility for saying a building is healthy? There's a big difference between talking in the round about healthy buildings and your professional indemnity being on the line to say that building is actually healthy. Like all of a sudden that concentrates the mind a little bit more. And I wonder if there's a little bit of an opportunity there with materials in that, right, if we're talking in terms of healthy buildings as this conference is, there's a lot at stake here actually. And so this isn't just something that you dismiss and put in a product, just believing a label. Like, you've got to be sure.
It's sort of, it's trying to get decision makers or stakeholders of any description really to understand that the chronic and the acute, the impacts of the chronic and the acute are equally damaging. You could argue that the chronic is more damaging. And that what you've highlighted there and the impact of indoor air quality is a chronic problem. So it's trying to get decision makers to see the importance of that. I mean, we go back to the food industry. There's a reason why there's such a body of research on how foodstuffs interact with moisture, and that's because you get an acute health problem and you get an acute economic problem if you get moisture wrong in food. The food industry ignores chronic problems. The best example, sugar. So I'm not putting the food industry in a pedestal. So what you see in there is an imperative to deal with the acute and an ability to brush the chronic under the table. And climate change is a chronic problem, and indoor air quality and the associated problems with that are chronic problems. And I think maybe as a species we've evolved to ignore the unthinkable or distant consequences. I suppose if I was in the forest 50,000 years ago, I wouldn't want to spend all my time thinking about whether there's a wolf or a bear is going to have me for dinner tonight, because I'd probably spent my life huddled on the top of a tree somewhere. So, I guess we're genetically predisposed to not think about terrible things. And unfortunately, climate change, the health impacts of indoor air quality are just maybe interacting with our natural behavior. So how do we get people to realize that you may not see this problem today, but it's there, and better off deal with it now?
Yeah, and I think there are lessons from food, and businesses and industries like that, because some of their version of the chronic risk is the chronic risk to their bottom line. By getting, by improving through iteration and getting better and better outcomes, there's less spoil. There's food lasts longer. There's better brand reputation. It's a competitive market. You're on the shelves next to other products the whole time, and there's a consumer protection element to this as well, right? And we don't necessarily have that in construction. That's been one of the challenges, is that we haven't turned some of these abject failures in the built environment into a consumer protection thing. Yeah. It's been a regulatory failure, which is a slightly different colouring, yes, I think, of the problem. Yes. But again, that's changing, and I see that in the built environment now, where you'll get a particularly vociferous WhatsApp group popping up in a new estate because people are measuring the performance of their buildings and they're going, hang on a minute, you sold me an A-rated home. This isn't an A-rated home. Yeah. I want my money back, or I want compensation for that. That's happening more and more and more. And I think as air quality and other measurements become accessible to people, they'll start to see this as a consumer protection problem. You said on your brochure this was a healthy A-rated home. I'm measuring something different here. Yeah.
And this is a problem. People's ability to assimilate and understand complex problems is going to be eased by AI. There's some things that you can put questions into AI and get some very good answers about. There's a lot of stuff that you don't at the minute, but that's only going to be moving in one direction, and people will be able to make more of an issue of things, I think.
Yeah, and I was having a conversation with a transparency organisation in the States about materials. We'll actually have this lady on the podcast in a few weeks' time. And one of the challenges they have with transparency of building products is the consumer's not in a position to understand what those ingredients are often, and definitely not into a position to understand the chemistry and the interactions and the risks associated with a lot of them. But again, that's changing with AI. That you'll be able to point your phone at a bunch of products in your home and it will be able to tell you what those risks are without you needing a chemistry degree, right? This stuff's changing quite quickly, and it, like you say, it might be difficult now, or you might not be able to trust the results, but even if they're not the results, you're in a very awkward position as a manufacturer of those products, those homes, because you've got somebody going, why have you introduced all these ingredients into my home? I understand that these cause cancers, or these cause long-term respiratory illnesses, or these might interact with these in a dangerous way, and I've got those symptoms. You can see that world changing really rapidly,
Yeah, definitely.
And I know, you talked to me about the transparency of materials, even within natural building materials, that it's a double-edged sword. You need to put that forward, but then also you have to say, well, yes, we are using this product in wood fibre, but we have to, because if we don't, this is the impact. So there are trade-offs and risks, aren't there?
Yeah, our products aren't perfect for everyone. Don't know what is perfect for anyone, but the best version of the state-of-the-art technology that exists today, and they're better in our opinion. And not our opinion, actually, we're trying to produce objective information through EPDs and such like. So, objectively, they're better in many situations. Could they be better? Yes. But we're trying to be a better version of something. We're not trying to be the best version. We can't be the best version of everything. Because that constantly moves anyway, as the environment evolves. So, we come in for a bit of flack because there's some recycled polyester in our insulation and some borates, and we're open about that. But the product, but there's positives to that. So it's not, and then at the end of the day, if you're providing information to people, you're giving them the opportunity to not buy it. If it's not for them, don't buy it. So, that's where we're at.
Explain a little bit about your company. What are the products that you do for people?
So our main product would be insulation made from sheep's wool. The kind of wool that's very bulky and coarse that you wouldn't use for clothing. And then in addition to that, we make a loft insulation that would be an alternative to fiberglass, and we make that from recycled PET, so recycled plastic bottles. Now, obviously, we're moving to a plastic-free world, but by taking that waste stream that exists currently and making insulation from it, that's doesn't shed fibers, is safe to handle, used as an alternative to, say, fiberglass in a loft, is a good way to take that PET, polyester, out of circulation, because what would happen otherwise would be it'd be recycled into clothing and microfibers discharged every time you wash the clothes, or it would be endlessly, or certainly, a number of times recycled into another plastic bottle. So putting it in your loft and leaving it there for 60 years isn't a bad way to deal with the mountain of material that's there.
Yeah, it's kind of carbon storage of another way.
And you could argue that, well, you're stimulating demand for the use of virgin polyester because you're providing an end use for the polyester. I suppose in theory that's got some legs, that argument, but in practice, people aren't making plastic bottles because we're making a relatively small amount of it loft insulation.
Yeah, I heard the same argument the other day for the environmental concrete. Somebody was, rather flippantly saying you need to thank the coal industry for the materials you're using to put into your environmentally friendly concrete. And he was going, yes, we do thank them, but until they stop using coal, then that's material waste that can seriously reduce the carbon impact of concrete. So yeah, we thank them, but that's the point of it. And it's similar with the, at a point in time, yes, it might be a non-sustainable source, but we're making it more sustainable by having an end of life. The sheep's wool is a different kettle of fish altogether, though, because that's a genuinely sustainable material.
It renews itself every year. But again, we do put recycled polyester in with that, but that helps reduce the packaging, reduces the carbon miles to site, and all that stuff. So it's in there for a functional reason. It binds the insulation together. It's the same binder that would be used in wood fibre or hemp, so it's not unique to us. But if we're open about it and people have got a choice. It's interesting you talk about the concrete. At what point do we shut the doors to progress? So if we shut the doors to sustainable concrete, we shut the doors to sustainable steel. We can't make the built environment purely from natural materials. It's not possible. We've closed all the doors to progress. Because we say, instead of taking stepping stones to get over the river, you have to go in one big leap. But what do we do? That's a challenge, isn't it? Is what does change look like?
And beyond the obvious kind of embodied carbon benefits of using something like sheep's wool, what are the other kind of benefits using that kind of material as an insulation product bring to a build? I know you've mentioned moisture control as one of them.
Well, wool uniquely reacts with formaldehyde. It's and again, I think we talked at the start about formaldehyde in the late 90s and MDF and all that. Formaldehyde is still a problem in the indoor environment. It just doesn't get a lot of press. But interestingly, wool has this complex reaction with formaldehyde, which explains why, going back maybe 20 years or more, they used to put it in shampoo. Because the reaction that wool has with formaldehyde that causes wool to destroy formaldehyde is the same reaction that gives your hair a nice luster when you wash your hair with a formaldehyde shampoo. It might knock 20 years off your life, but but it gives your hair a good luster. And that's a really good rationale. You mentioned wool carpets at the start. That's a good rationale for having wool fabrics within within your living spaces, because they can really mop up that kind of thing and destroy it.
What do they do? Is it just is it a chemical reaction level? It's turning it into something else?
So it's what's called a condensation reaction. So the formaldehyde, which is a tiny little organic molecule, it reacts with the wool fibre. The carbon bit of the formaldehyde gets incorporated into the actual backbone of the keratin protein, and you get a water molecule coming off, which is why it's called a condensation reaction. So actually the formaldehyde builds itself on top of the wool fibre.
Interesting. Does it have a kind of a limit? Like will the wool get full up at some point and need regenerating?
Well, there's two stages. One is as temporary, and then that converts to a permanent phase. But there's so much active sites and capacity within the wool fabric that, for that to happen over the lifetime of the wool, it would, the least of your problems would be whether your wool's absorbing enough formaldehyde.
Yeah, and this is the beautiful thing about materials. That this is science that we're continuing to learn about. We've seen the Nobel Prize last year was won by Metal Organic Frameworks, MOFs. And these are showing remarkable abilities to translate harmful chemicals into benign water and other things, and formaldehyde was one of them with the MOFs as well. So materials I think are going to continue to play an important part, not just in not introducing risk into a space, but perhaps also assisting and eliminating risk as well.
So when you're looking at, when you're going back to this sort of idea of hurdle technology or Swiss cheese, it's adding extra dimensions to it, and when you're looking at what AI is introducing to, chemistry and chemical modeling, those complex reactions that you've talked about, it's become impossible to model those.
Yeah, it's really interesting.
And to come up with some chemistry or something that can neutralize it.
What do you see as the trajectory for the sustainable building materials over the next kind of decade then? As someone that's been involved in this sector for so long, what are your hopes for it over the next kind of 5 to 10 years? Are you seeing some directions of travel that are encouraging there? I mean, you kind of hinted at it earlier that you feel like there is some forward momentum here.
I think where we're struggling at this moment in time in the UK is a sort of economic environment. Construction's in the doldrums a little bit. So I think an uptick in the economy and people's willingness to invest is going to help. I'm not optimistic there'll be a lot of policy that's going to drive things in the next 5 years. I think the government has sort of set their priorities as they have. So I think a lot of the change is going to be led from the bottom up, client-driven, household-driven. The innovations are probably going to come from looking at the existing policy framework and legislative framework and thinking, how can we affect change through the existing landscape rather than sat endlessly waiting for policy to change, which it needs to change, by the way. I'm not suggesting it doesn't, but so when change comes, I think it'll come more quickly. And I think what we have to do is convince government that the capacity to deal with that rapid change already exists. So if you're looking at going back to natural fibre insulation, these are existing technologies that are already and can be manufactured at scale. If you think of natural fibre insulation in Germany and France, it's already about 15% of the market. So the knowledge base, the skills and the capacity to fill the market exists. So it's important to get, because I think one of the big barriers to shift to a change in the market is for policymakers to believe that they would like change to happen, but the industrial capacity just isn't there and will take too long to implement. And therefore, we might hit another one of these inflection points that we've talked about, and change comes quickly, but it comes somewhere else that we weren't looking at or looking for.
And perhaps conversations like we have today at the Healthy Buildings Conference are important jigsaw pieces in that bigger puzzle, because, you know, while we might not have the headroom in energy, that it's well understood, that embodied carbon is well understood, and there may be not too many changes coming in the short term there, perhaps healthy buildings and the impacts of, you know, sustainable and natural building products, there's some headroom there to really make some difference and create one of those inflection points.
Yeah, and I think, you know, if I look at my early life, you asked whether I'm optimistic. You know, I grew up in Belfast in the 70s and 80s, which wasn't a pleasant place to be. And I learned two things from that. You know, I guess from, you know, until my early adult life, it was inconceivable in my mind that there could be peace in Northern Ireland. But it came, and when it came quickly, and it's lasted. And the other thing is that in order for change to happen, polarization has to be dampened. People have to move away from entrenched positions and accept that people have opinions that differ from theirs, and that their opinion has got some validity. So I suppose that's ingrained in me. That sense of optimism is ingrained in me because I've experienced it through a different mechanism. But the process is the same.
Yeah, that's really interesting. Well, Mark, it's been brilliant talking to you this morning. I really appreciate you taking time out of what's going to be a very busy day for you and the ASPB in general. I think it's a really important day. It keeps health and the indoor environment front and centre in the conversation with materials. So really looking forward to the conversations that are going to be had today. And I think this has been a really important part of it. So Mark, thanks so much. Really appreciate your time.
Thank you.
Thanks for listening. Before you go, can I ask a favour? Before you shoot off to whatever it is you have to do next, or even the next podcast, if you enjoyed what we've been talking about here, please do spread the word and let's keep building this community. And don't forget to check out our sponsors in the show notes: Ultra Protect, Eurovent, Erico, ACO, Farmwood and Zender. All amazing companies, and without them, this podcast would just simply not be possible. Check them out in the show notes at airqualitymatters.net, and do check out our YouTube channel. All this content is there, plus much more. See you again next week.